So as I was saying, we know that the car on the right has a momentum that is 1.5 times larger than the car on the left. Now we know we've just calculated the car on the left has a momentum 1 kilogram meter per second, so it's simply going to be 1.5 times that, so 1.5 times 1, which is equal to a 1.5 kilogram meters per second. Remembering our units, extremely important in physics because it's pretty easy marks and it would be a shame to miss out on them. So we know the total momentum before they collide is the momentum of this one here, which is 1 kilogram meter per second, plus the momentum of this one here, which is 1.5 kilograms meters per second. So if I simply just add those two together, 1 plus 1.5, no, you don't even need to really calculate that, you know it's 2.5. So the total momentum before they collide is 2.5 kilograms meters per second. Now that is, I'm just going to say that's T, and that's the total over there. And then it says, what is the speed of the car on the right before impact? So we want to find this velocity or this speed here. Now if I just move up slightly, now we don't actually know the mass, so therefore we're going to have to work it out from the momentum. We know the momentum of the one on the right. Oh, we do actually know the mass, sorry, my apologies. We know that they're both 0.2 kilograms, so that makes it a bit easier. Otherwise it would be almost impossible to work out without some very complicated mathematics. So I know that the momentum on the right is 1.5 kilogram meters per second, and that's equal to its mass, 0.2 kilograms, times by its velocity, which is this way. I'll just call it v. Now simply all I have to do now is rearrange this, so it's simply going to be 1.5 divided by 0.2, and that's our velocity. Now I'll just stick that in the calculator quickly, make it a bit easier. 7.5 meters per second, because it's a velocity, it's going to be measured in meters per second. Then it says, calculate the final velocity of the two cars after colliding non-elastically. Alright, so we have to find we know the total momentum of both of them here, and we know the total mass of them there as well. So in order to find the final velocity of these two vehicles, all you have to do is put the 2.5 there, so 2.5 kilogram meters per second, okay, because that's our momentum, and our momentum of both of them together is going to equal their mass, so 0.2 plus 0.2, so the total mass is 0.4 multiplied by this velocity v that we want to try and find, and then simply we rearrange this. So I move this under here like so. So 2.5 divided by 0.4, chuck that in your calculator and you should get 2.5 divided by 0.4, 6.25 meters per second. Like that. And I think that's done, so I hope this has helped, and just see if you can check your work and see if you can correct any mistakes you made. Alright, thanks guys. So just carrying on where we left off, we know the momentum of the car on the right, so this one here, if I scroll up slightly, this one here is 1.5 times the momentum of this one over there. Now if we take the momentum on the left, it's 1 kilogram meter per second, so the momentum of the car on the right is simply going to be 1.5 times bigger than that, so 1.5 times 1, and that is going to equal 1.5 kilogram meters per second. Now if you do put this on your diagram, you'll realise that the momentum of the car on the right is bigger than the momentum of the car on the left. And because they're going in opposite directions, we have to take that into account when we work out their total momentum. So if it's 1.5 going this way, and only one, like that, 1 kilogram meters per second, 1 kilogram meters per second, like so. So we know now that the total momentum will actually be towards the left, this way, because this is much larger than that. And in order to work out how much it's going to the left, it's simply going to be 1.5 minus that 1 there. So 1.5 minus 1, so the total momentum before they collide is a half kilogram meter per second, and it's to the left. Generally because, just to explain it again, the one on the right is going at, or has a momentum of 1.5 kilogram meters per second this way. This one on the left has a momentum of 1 kilogram meter per second, and it's going to the right. So the total momentum, when we actually, these will cancel each other out, because obviously in a collision they're going in opposite directions, they will cancel each other out, and this car will actually be the stronger one, so its momentum will be carried through as the total momentum. So that's where that half, that relative half, comes from, because of this one going to the left. So it says, what is the speed of the car on the right before the impact? Well, we know the momentum of the car on the right now is 1.5 kilogram meters per second, so I can put that into the formula. 1.5 kilogram meters per second. So momentum is going to equal its mass, so 0.2, times by its velocity, or its speed in this case, which is the thing we want to find, so times by v. And then simply we rearrange this like so, so you get 1.5, I move that under there, so I divide by 0.2, divided by 0.2, and if I work that out quickly, that's going to be 7.5 meters per second. Okay, so then it says calculate the final velocity of the two cars after colliding non-elastically. Well, we know that the momentum of the two cars after they have collided non-elastically is this 0.5 meters per second going to the left. So we know both cars are going to travel to the left with some velocity v that we need to find. So we have here 0.5, which is my momentum, is going to equal the two masses together, so 0.4, and that's kilograms. I've just left off my units, which is not very good practice. Let's correct that up there. And I'm timesing that by the velocity of both the cars together, which is what I want to find, them going off to the left this way. I call it v, just for the sakes of argument. Then all I have to do is rearrange this equation, simply take the 0.4 to the other side, you get 0.5 divided by 0.4, and that's my v there. And if I simply just put that in the calculator quickly, you'll get 1.25 meters per second, and as it's a velocity, you can say it's to the left. Okay, to the left. Okay, hope that's helped, guys. See if you can check over your answers and correct any you don't understand, and come and see me if you're still confused about some of the answers on here. Alright, great. Thanks a lot.